Hello and welcome to Voices of BlueScope, the podcast where we go behind the scenes at BlueScope to meet the people who create strength every day. I'm your host, Martin Feld. Thank you for listening. In this first episode for 2023, we're highlighting the importance of sharing corporate knowledge across teams and with new generations of employees. As a case study, we're focusing on a significant topic that most have probably never considered: gas safety regulations in steel manufacturing. You'll hear conversations with 4 people who all have experience with gas safety at the Port Kembla Steelworks in Australia, with varying backgrounds in chemical and process engineering. They are Richard Ainsworth, Ian Hodges, Jennifer Blood, and Krishan Kumar. Let's begin with an extended interview with Richard, who retired from BlueScope late in 2022 after 4 decades with the company. Richard is credited with constructing gas safety regulations at BlueScope, which continue to be used and updated today. In his story, he also describes how he turned a personal challenge into a key advantage.
I started working in the steelworks straight out of high school as an engineering cadet, and that was in 1980, so a long time ago. Yeah, and it was a chemical engineering cadetship. So I went through university, but also worked here at the steelworks. And then when I finished my degree, I came back as a graduate to work at the steelworks. Yeah.
And what was it about working at the Port Kembla Steelworks that appealed to you back in 1980? What prompted you to join?
Yeah, that's an interesting one. So, see, I was from the country, so the biggest piece of machinery I'd ever seen was a tractor or a truck on the road. Though, no, thankfully I had a good careers night experience when I was living out in the bush, and I happened to talk to a chemical engineer because that person was doing an R&D project in this rural community to try and find a use for rice husks, which was a waste product from the rice industry, and they were trying to work out whether they could burn them and generate electricity. And when he explained that whole project, I just thought that was so fascinating, and I said, where do I sign up for this type of work? And he said, go to uni and become a chemical engineer. So I'd already knew I wanted to be a chemical engineer before I found out about BlueScope's cadetship. So I found out that through a mate who had a family here in Wollongong. Yeah, so
awesome. Before we continue with that, though, did you ever find out what happened to the husks?
Yes, I did, because it was still stuck in my mind years later. And I did inquire with a few people, and they could never quite get this fellow's idea working. Yeah, but I think there's been other attempts. But yeah, the idea of burning it to make steam and make electricity, it was just technically a bit hard. Yeah. I think they have found some other things they can do, and there's a lot of stuff in the media at the moment about carbon capture. Well, it's in a way a rice husk. Yeah, it's all this cellulose has all this carbon in it, and they're finding other ways to try and get it back into the soil.
There you go. A minute in, we're already exploring other projects.
Yeah,
that's great.
Yeah.
So on to that start with uni.
Yep.
You've moved. You've embarked on a new kind of academic adventure.
Yep.
Tell me about what it was like to get started on that and that journey that took you to where you are now.
Yeah, so back in those days, well, and it's even similar now, if you did a cadetship, you worked here at the steelworks, basically full-time, but you got one day off a week to go to uni, so the university was part-time for the first 2 years, and I was based here in Wollongong, and then we went to full-time uni in Sydney for 3 years to finish off the degree, because they don't actually have chemical engineering at Wollongong Uni. But that process of transitioning from the country to here, that was pretty good. There was a lot of accommodation provided by the company or organised by the company back then, but it was such a heyday for recruits. There wasn't actually any space at the company accommodation, so but the company still organised for me to live at International House, which was part of the university accommodation, like a college for the university. So that was a little bit different, but yeah, BlueScope were very good at helping young people like me making that transition from the country to a more metropolitan environment. Yeah, and those first 2 years are very good in that cadetship program. because you get to see all the practical side of it. You're really just an assistant for the engineers and anyone older than you, basically. But that gives you a visual and a practical taste of what it's like before you go off and learn all the theory at university. So that was a great way of piecing it all together, because when your lecturers are talking about pumps and control valves and things, well, I've seen them, I've played around with them already, whereas a lot of the people that went straight out of school through university don't get that, unfortunately. So that was quite good, and it sort of confirmed that yes, I liked all that practical side of things and I liked engineering, and so I stuck with it. I was happy to come back to BlueScope because I wanted to come back with my full engineering stripes, and get stuck into it. Yeah.
So you had that balance of theory and practice that a lot of people didn't.
Yes, that's right. It was fairly obvious going through university when we did things like at full-time university in Sydney, when we did anything practical. Yeah, it was clear any of the BlueScope cadets would be helping all the other students, going, well, yeah, that's, this is what a pump does. That's what it looks like inside, and that's, this is what can go wrong. And it's, that side of it was just invaluable in the degree process.
And you mentioned chemical engineering as a discipline there.
Yes.
I'm sure a lot of people who are listening, particularly if they're not part of BlueScope or a similar manufacturing company that has people who do this, they might be thinking, okay, well, there's chemistry, but then there's chemical engineering. So in maybe layman's terms, or as a bit of a quick crash course, what would you say is crucial or interesting about chemical engineering and distinct from chemistry?
Yes, and a lot of people make that mistake. They think that you're working in a laboratory. Well, no, the people who work in laboratories are industrial chemists. So, that's really into all the chemistry, the test tubes and beakers and things. Yeah, the way I explain it to people is, that's all the same concepts, all of those concepts of chemistry and physics. Though to be a chemical engineer, you've got to take those concepts out of the laboratory and apply them in industry. There'll be some chemical or physical process going on, but it's the engineering around it, to make it happen in the way it's intended. That's really the purpose. So again, that appealed to me, that putting things into practice. I understood, I loved chemistry and physics and maths at school and all that sort of thing, but the idea of taking it from that theoretical stage and then actually applying it to manufacturing something, I thought, that's for me. That's the big difference. A chemical engineer would rarely, you would rarely see them in a lab. It would only be, here I've taken a sample of something, I'd take it to the lab so they can analyse it, and so I can get the results back and work out, what's going wrong with that process, or how can we modify it to make it do what we want. Yeah, that's the big difference to me.
No, that's a great explanation. And when you did start your career there and you were getting that first taste of that industrial environment, what was your impression of walking into that workplace, and what kind of machines or settings were you exposed to?
Yeah, just how huge. Well, what took me back was just how huge everything was, because, like I said, the biggest thing I'd seen before coming here was a tractor. Yeah, everything was on such a massive scale that just even the buildings that house, the steel making plant, they're just huge, and our blast furnace is 60, 70, 80 metres tall. They're such huge structures. And I must admit also, I was impressed with the amount of energy that, physical energy and heat energy and all that, and electricity, just the amount of energy that goes in to a place like this. It's just on such a huge scale. Yeah, so it's just the size and scale and the magnitude of everything is what really impressed me. Yeah.
And once you became accustomed to the environment and you completed your time training as a cadet, where did your career take you from there? Because no doubt you moved on to a different kind of role.
Yes. So when I graduated as an engineer, I remember the fellow at the time who I was assigned to. He had spent a lot of his career, or early part of his career, working in coke making, but for whatever reason, leading up to that time that I came back from university, they'd really lost the on-site presence of a chemical engineer, or we call ourselves process engineers, on site. And he was of the opinion, you really needed your process engineers to be with the operations and maintenance people day to day, shoulder to shoulder, to really understand what the issues were and to help them and work through those issues with your own expertise. And it's pretty hard to do that from a remote office, but there had been this tendency that the people who worked in the coke making area were off-site. They lived in the engineering building, so it was cleaner and nicer, I suppose. So what this fellow said to me is, look, I want to send you to the coke ovens, but on one condition: you have to go down there and establish a base, an office, and if you do that, as more people come, they'll go into that office. But I was like the pioneer, I suppose. So he said, if you're prepared to do that, I'm giving you that role. And I said, yep, sign me up. So I went on my own as a process engineer, but established a site office there, and then it very quickly grew, and it improved our presence in the area. And yeah, straight away. But if you're there every day and you're hearing what the issues are that are facing the organisation, you very quickly realise, if I insert myself there, I can help those people sort that problem out. I can insert myself there because you see that they're struggling and you've got the knowledge that they might help them. Yeah, that was great. I just loved it because I could make a difference very quickly.
And a huge step up in responsibility.
Oh yeah, that's right. That was part of, I suppose, what this supervisor was saying was, I'm going to put you there on your own. If you're happy with that, that's what we're going to do. But if you want, don't expect to have someone more senior guiding you. I'm going to send you out as a lone wolf initially. And I said, yep, okay, I'll do it.
What do you think was one of the biggest lessons that you learnt in that role at the time and setting all of this up?
Oh, well, biggest lessons. I would say just how important communication is, because you're dealing in that role. I was dealing with people, that were operators, perhaps necessarily not tertiary educated, or maintainers that are more on the tools and things. Though if you're prepared to hear the message, they'll have a problem, but they might not be able to put it in particularly technical terms. But if you're happy to talk to them and get them to tell you what the problem is, and then put it back in your own words to see if you're working out what the actual technical issue is, that's so important. You can have all the smarts in the world, but if you can't communicate with people that are from a different field and in a different way of communicating, it's a bit useless. That knowledge that you've got, if you can't, you're going to find it very difficult to put it into practice. So I learned very quickly that listening and trying to understand and repeating things back to people to get to the heart of what the issue was.
How do you think it changed you in your work?
Those early days, well, it showed me, because I had some early successes, it showed me that, I shouldn't be afraid to be down there shoulder to shoulder with the people. And if they have an issue, say, well, take me and show me, and when does this happen? Yep, let's go and have a look together. That gained a lot of respect and trust off the workforce that I was working with, that perhaps don't necessarily, they weren't used to having an engineer like me around. So it's like, who is this young fellow that looks like he's just out of university? And that taught me right from the early days, not to be afraid to go and stand shoulder to shoulder with the people. To get in there with the people that have got the issue, so you can help them fix it.
No, it's important to be able to communicate with people with all different backgrounds.
That's
absolutely.
Right. Yeah.
Now, something that you've become known for, or highly involved in, if we can put it that way, is the importance of gas regulations.
Yes.
Now, that's something that you've done for quite some time now. Can you tell me how you shifted from this process engineering focus after you completed your cadetship to move into this really important space, and maybe explain why it's so important? Yeah.
So, again, in a way, because my first placement was coke making, they do have a lot of these hazardous gases. One of the hazardous gases that we produce ourselves is produced in coke making, that's coke ovens gas, but also, and they burn it as a fuel, and they also burn blast furnace gas, which is another byproduct gas that we make in the steelworks and reuse as a fuel. So it was already a very gas safety intense area, so I knew I could see how, working there, how much of these gases were around and used, and heard a lot of the stories. Some of our worst incidents that we've had in our history, it had happened in that plant, and they were very good actually, that even when they first showed you around, they'd take you to the side of one of the worst incidents and and show you and tell you. So they're very good at keeping that sort of corporate knowledge in that respect, saying, well, this happened and people died here that day. That was in the 1970s, way before my time. But so it was already a department that had a lot of knowledge. And then again, this same supervisor, his name was Sid Webb. I should give him kudos. Everyone, all the process engineers should never forget that name, because he was really quite a stalwart. But after I'd been at the coke ovens for 3 or 4 years, he then started to direct me to help out with some other work. And he said, well, you get involved with isolating the gas systems, and find out what's involved. And then he sent me on a few jobs with Energy Services, which is they're the people that look after all of the distributing all the gases around the steelworks. So they were again a very gas safety intensive department, and he sent me on a few jobs with those people, and so I got to see what they did, help out, understand some of the issues. And then around that time, so around sort of 1989 or something like that, I think it was, there was a shift in the way the organisation sort of dealt with gas safety, and they decided that they wanted a number of people of engineering types like me to step up into this role of checking gas procedures. So every time you do gas work, so working on a hazardous gas system, there has to be a written procedure, but they'd instituted this thing where it's independently checked by 2 people, not just one. So I was one of the first batch of engineers that were sort of nominated to become these checking officers. And that was again because of this fellow that I was working for, Sid. He said, "Oh, Richard, I think you." But I could tell that he'd been shaping me a bit, making sure I got broad experience in that area. And then one day he said, "No, well, I'm putting you up as one of these people to check gas procedures." Yeah, and that's really when I got heavily involved in the whole process.
Were you appreciating at the time just how widespread gas was as a tool, as a mechanism, as a way of keeping this thing running?
Particularly the coke ovens, because there was quite a lot involved there. Yeah, even as a cadet, the good thing about these cadetship programs, unfortunately we don't run the process engineering cadetship program anymore, but the benefit was you got rotated. For every 6 months you'd move to a different department, because you were really just a helper to help the engineers out, so you got a bit of experience. So I had already seen, in going through my degree, I'd seen the breadth of gas usage and that across the steelworks. Yeah, so I knew it was widespread. Yeah.
Am I correct in saying that you were also in your career instrumental to drawing up and refining regulations?
Yes. So once I became this checking officer, and then I moved departments. I went on to a project where we were compressing coke ovens gas. We were going to compress coke ovens gas to inject into the blast furnace. I knew a lot about coke ovens gas because I'd worked with the coke ovens, and so that project was good. And then that was a transition into the blast furnace department for me. Mm-hmm. So I moved and that's another sort of gas intensive. That's the other place that we produce a lot of gas and also consume a lot of gases. And I got promoted to be a senior engineer then. And I'd worked there for a while, but again, all the while being involved in, because when you're a checking officer, everyone has to bring their procedures to someone who can check them. You tend to know what gas work is going on in the broader area, not just the department where you're based, because all the other departments need other people to check their procedures. And there is, back in those days also, we stressed a lot on saying a checking officer, at least one of them should come from another department to get that cross-pollination, to make sure you didn't develop little work practices within your own area and everyone thinks it's okay and you've never had any external viewpoint on it. So I got a broad view then, and the isolation regulations came along. So way back in those days, so in the sort of the 90s, we were still using paper tags to put on valves and things when they were shut for someone's safety, to isolate something. We were using paper tags, but there was a problem with them. They could blow off in the wind. If someone, they could get knocked off accidentally or whatever. If it rains, they all smudge. You can't even read them. So there was a big transition to go to locking and to lock all valves that were required in isolation. Now that's just, everyone just understands that these days, but I was involved when that transition happened. And because of the way we do gas work, there's certain hazards present right through until you've removed all the gas. Whereas when you're doing a more simple isolation like turning off water, You turn off the water stops coming out, you know it's isolated. Or you turn off a less hazardous thing like compressed air, you turn it off, the pipe depressurises. Electricity, you flick the switch, there's no more electricity, you can test, there's no more electricity. But with gas, it's still quite hazardous until you've removed all the inventory of gas out of the system. So when we were trying to apply the isolation regulations to gas work, there was a few anomalies and inconsistencies because the isolation regs hadn't really been written necessarily with gas work involved. And I do remember the day I got involved in a fairly interesting discussion with some people on site. They were auditing a job that I had been involved with preparing and checked the procedures and said it was all okay. And these people said, but you should have put a lock on that valve. And I said, well, no, that valve, we have to operate this valve throughout this process that we're doing to make this gas system safe. Because you have to, with gas systems, you have to purge the gas that's in there out with a safe gas like nitrogen or steam or an inert gas. You remove the flammable gas with an inert gas. So you're opening and closing valves all the way through until it's safe. And I said, well, no, there's no way I'm putting a lock on that valve because I have to come back and turn it later. And also that valve has to stay open. I'm not going to put a lock on it because if it has to stay open, but if something goes wrong and I want to close it in a hurry, I'm not going to have a lock on it. It's still in play. It's not really isolated till the gas is removed. And I kept trying to explain this to people. And what happened was a manager said, look, this fellow, he didn't say it to me, apparently he said it in some other meeting, I just heard about it later. They said, this guy's clearly thinking very hard about isolations, and about the way gas work works. So they nominated me to revise the gas regulations because they said, and the gas regulations we've done bits and pieces to it, but as a whole document, we haven't revised it for many, many years. So my name came up as a person to go and do this major revision of the gas regulations that happened in the late 90s.
So is this something that you foresaw for yourself?
No.
This kind of expert
that was a bit
knowledge?
Of a... No, it's... That's right. It was a surprise. It's because I was just applying logic that I thought was quite logical, and said, "Well, no, that's a dumb idea, or that's a smart idea, whatever." No, I didn't foresee it, but when I was asked, like that other example, when I was asked, "We think you'd be the right person to do this. Would you do this?" I said yes.
So when you were designing these new regulations, no doubt there's some research involved in that, or you're having to work with different people. How much of a challenge was it to actually put stuff officially on paper and institute this across an organisation? Yeah,
that was an interesting exercise because, again, it requires a lot of communication. You have to be able to talk to a lot of people and say, well, what's been annoying you about, or what's some inconsistency in our current gas regulations that needs to be fixed, or if we were to change it, start with a blank piece of paper, how would we have it? So there was a lot of consultation. Though I think I'm a little bit different to a lot of other engineers. A lot of engineers are very introverted, and they work on their own. They just want the books and the issue, and then leave me alone, and I'll come back with the answer. Well, I'm a bit different. I'm more of a extroverted person anyway, so I was quite happy to go around and talk to people, and get all their feedback and find out what some of the issues were. That I quite enjoyed that part of it, that aspect of the job. Yeah, the actual rewriting of regulations, well, it's not very attractive sounding work, writing regulations. Though I suppose it wasn't like I wrote it from scratch. There was already things there, but I had to look at, how can we evolve this and make it more user-friendly, more useful, more accessible to people, not just this little group of experts, So I suppose I forced myself to do the writing part of it, and that was okay. But I was more interested in getting a product that was more user-friendly. So you force yourself to do some things so that you can do other things that you're good at, or you like doing. Yeah, I actually told someone the other day that I must be all right. Yeah, I know I must be good at writing these sort of official documents because they have stood the test of time. And I was sort of wondering why it was. And I think, but I trace it back to I'm dyslexic, right? And so I get, when I read things, I see letters back to front, if I try to spell, I'm a terrible speller and all that sort of thing, and I put that down to having this sort of mild dyslexia. But it means that I read things very carefully, and I read every word, and I sort of read it and think, what is that telling me? What does it mean? You know, so through that little quirk, I read things very carefully, and I remember them because I read them so carefully to make sure I'm reading it right, and I remember them. And also, I got a hang for the way, if you write things a certain way, the message will be clear. Yeah, you can write something and take a page, but if you can write it in a couple of sentences and write succinctly and get that the message, again, I think I put that back to my dyslexia. I'm just like, don't give me 1,000 words to read. I'm a slow reader, and because I have to read things carefully. Well, that sort of taught me to write things succinctly. Like, what's the intent here? What are we trying to achieve? Just say that.
That's really wonderful that you've shared that, and I appreciate that, because I'm guessing when you were first asked to draft or then publish these regulations, if you had made mention of or made a big deal about your, as you say, mild dyslexia, they might not have thought that you were the guy for the job, but it's actually completely shaped effective communication of this.
And there was a little bit of mild terror on my part as well. I was like, you want me to write all this stuff? But that's it turned out to be a good option, and it's like you say, force yourself to do some things because you're good at others, and it all has to work together if you're going to create something.
And turn that challenge into an advantage. Ultimately.
Yeah.
That's really good.
Yeah.
Now, from what I've been made aware, you are very close to retiring after over 40 years. 42
years, yeah.
Congratulations!
Yeah, thank you.
That's very impressive, and we have a lot of very long-term people at BlueScope who've performed in a variety of different roles and made very impressive contributions. As you draw closer to this retirement and you think about this contribution that you've made in these regulations, things that affect people across operations at BlueScope, how do you consider your time here and your legacy and what it means to transfer knowledge to other people?
Oh, well, it's very important. Yes, that's... I was talking to a young fellow the other day as well, a young engineer. I said my name and he said, "Oh, your name's on everything." And I said, "It's not everything, just stuff you've been looking at recently." But so that's right. I realised from this early activity of revising the whole gas regulations manual, and I didn't do it on my own, I must admit. There were lots of people involved, but I had to pull it all together. The value that has for the organisation, because it gives everyone this common resource that they can all go to and understand their part in it. Just the value that gives an organisation, because really not many places would do that. Most places would just rely on what does the government regulations say. What does it say in the occupational health and safety regs or whatever? Well, because we've got such unique hazards here on site, because we produce a lot of our own gases, we had to be our own regulatory authority, because you couldn't rely on the government to tell you how to safely operate the gas system on a blast furnace, because there's not many others in Australia. Well, there's none now. We're the only ones. Oh no, there's Whyalla. Sorry, Whyalla does have a blast furnace. But so it was a bit unique. But I guess I've seen the value that people get out of it, out of having a well-written document and a well-respected document. And it's just so I use that in other things. I took over. I took in our confined space system as well. I haven't just written the gas regulations. I was involved in that, and I think it was for the same reason, because I'd done okay with the gas regulations while we were having problems with our confined space system. So I sort of looked after that for 10 years. Not anymore. I moved on. And gave that a large rewrite. And I suppose what makes me feel good about that is once you do a good job on doing that foundation, that's just the foundation. You need people to access the information and turn it into practical experience and to go out and do things safely. Well, you could see with the gas regs, we were having less incidents, less bad things, less close calls. So that's the reward. Well, it was the same sort of thing with confined spaces. So it had a problem, there was issues, we were getting grief from the external regulatory authorities about our system. But once, after spending a few years on it, those problems just go away. That's how you know you've done a good job in reality, because that foundation, then everything else gets built off it, and it's just the wheels start turning and everyone knows what to do.
And out of curiosity, how many confined spaces did you personally have to enter?
Have I entered?
Just because it sounds mildly terrifying to me.
It is, yeah. Quite a few when I was a young engineer. Like I worked on the 7A battery project when we built 7A battery. And because I was the youngest engineer on the job, there was one job where you had to inspect the internals of the pipe before they were closed up for the last time. So the construction people build it, and then they, clean it out, supposedly clean it out, and pressure test it. But before you finally box everything up, you say, do up all the bolts and say it's ready to accept gas. Someone had to go through the pipes. Well, I was the youngest engineer on the job, so it was me. So I had to crawl through. I've crawled through every pipe you could crawl through, basically, on 7A battery and the associated equipment, because that was my job, do the final crawl through. And, lucky I'm not claustrophobic. If you were claustrophobic, you wouldn't do it. I do remember crawling in one pipe that you couldn't turn around in it, so you had to crawl in and then reverse out. There wasn't enough space to turn around. That was probably the least comfortable I was, but there was a rope tied around my waist. They could have dragged me out if I had to, but it was, again, I learned, I suppose, off some experienced engineers on that project, and so even though not a lot of it was written down, the particular engineer, he had quite a good grasp of, we're not going to lose Richard. We're sending him up the pipe, but we're bringing him back out. So yeah, I knew what it felt like being inside, and you do feel vulnerable. So it's nice to know that there's this whole system around keeping you safe when you're inside, because there's a person outside that's their main job, is to keep track of you and monitor the atmosphere and all that sort of thing. So yeah.
And in that story, you reflected on being, as you said, a young or new engineer, or one of the new ones on the scene. Now that you've been working with, new generations coming through, people using and referring to the regulations and different things that you've brought in and put into place, how does that make you feel, working with new people coming in and using those things?
Oh, look, it's very gratifying, yeah, because you know that hard work you did years before is still benefiting people. It gives them that good head start where they don't have to learn lessons the hard way. They say you can learn a lesson the hard way, like make the mistake yourself and hopefully survive. Or you can learn those hard lessons, beforehand off by benefiting from other people's experience, I suppose. So, yeah, history's a hard teacher. So what I find is very good is where the younger people that come through, when they read what's written down in some of these documents, and then they start to think critically, and then they ask questions where you realise that, they're really getting into the depths of this and understanding the principles behind it. So that's very gratifying, because you've done your job. Then you've made them. You've said enough to say, when you think this through, you can logic yourself to the same point. That's all I've been doing all the way along, is going, well, what's sensible, what's achievable. It's got to be practical and achievable. Well, you're on the right track, because it's exactly the way I was thinking when I wrote those words. That's very gratifying.
And my last formal question for you, I suppose, is less work related. What are you looking forward to in your retirement? What's ahead for Richard?
Oh, well, my wife has a vintage business, a vintage shop, so I'll be helping her. But I've told a lot of people this story in recent times, because this is what I'll be doing. Like, one of the things is we sell vintage vinyl records, so I'm the curator of the record collection. So I get them, clean them, play them, grade them, and put them out. And that's led on to repairing turntables, because everyone needs a turntable to play their vintage vinyls on. What better than to buy a vintage turntable? So I found I've actually got some reasonable skills in repairing turntables and other things like that. So that'll keep me busy. I'll be looking forward to working with my hands more. I've always been a sort of fairly hands-on person. Nowadays, you have to sit behind the computer. I suppose I'm looking forward to not sitting in front of a computer each day, and doing more practical things with my hands, in a different area. Perhaps having a sleep in every now and then.
Sleep-ins are good. Sleep-ins are very good.
Yeah.
Now, is there anything that I haven't asked you about your career, where things have been going, that you'd like to cover before we finish?
I suppose another experience that really helped me develop as a professional was I was seconded over to Western Australia for 2 years on the hot briquetted iron plant, HBI plant they talked about. It was when we were all still part of BHP Billiton. But that working on that facility, that really impressed upon me the importance of process safety as a field, and process safety has sort of grown a bit in the steelworks. It's grown out of the gas safety system because a lot of the hazards are to do with gases, but there's other process safety hazards, so that's a new field. But that working there for 2 years and going, seeing what I saw there, I realised, the importance of that whole field of process safety. So, and that was a 2-year secondment. So when I came back, I did say to my boss, it was Sid still, so Sid Webb's name keeps popping up. I said to him, Sid, we've got to get onto this process safety because it's coming and it's a good approach, and that business over in Western Australia, it was governed by that legislation, there's specific government legislation which hasn't directly applied to the steelworks at the moment. But I said, look, this whole area, we've got to upskill in this area. Sid understood what I was saying and said, yep. And he said, you're the right person for the job, Richard. So go, get in to learn more about process safety. And that's, that for the last sort of 20 years of my career, I've been doing that as well as the gas safety because it was a natural fit. And that is a big, there's a lot of activity going on in that area. But it all came from that opportunity that was given, and just say yes. I could have said no. I wouldn't have gone to Western Australia. I wouldn't have got that experience. I would have stayed, maybe ended up working somewhere different or whatever. That's one thing I'd say to young people. If you get presented with an opportunity, try to find a way to say yes. Yes might not be the right answer for everyone in the right situation, but the more you say yes, the more opportunities you'll get to broaden your experience and improve your career.
That's a great message to share with people, so thank you. And look, not only have we learned that, but I think in talking to you, what has come out again and again is whether it was the safety regulations or the confined spaces or WA, you were the guy for the job.
Yeah.
It's good to be recognised in that way and be given those opportunities as well.
Yes, that's right, definitely.
Well, look, I want to say thank you for joining this recording and sharing your experience. Yep. It's been great to have you on Voices of BlueScope, and all the best for your retirement, Richard.
You're welcome. Thank you.
Next up, let's hear from Ian, who explains the safety framework further and contextualises gas as one of various important utilities in steelmaking.
My name's Ian Hodges. I work as the Energy Services Operations Manager. So that's primarily based down at number 2 blower station, but covers a wide range of areas, including all the gas distribution networks and some gardens and roads and sewage plants and recycling areas as well.
So you have to take care of quite a few assets, it sounds like.
I have to make sure other people take care of them, yes. There's a lot of good people doing a lot of good work, but overall, it's a wide-ranging role, but focused primarily on the delivery of energy and utilities to all the site users so they can run their plants is really the bottom line of what we're trying to do.
There are a few words in there that I think people outside BlueScope may not be quite across. For example, blower station or energy services. You talked about ensuring that energy is around the place or supplied. Can you give us a little bit more of a definition of where you're situated and what goes on there?
Sure. So the blower station itself is really named because of the blowers, which are steam-driven turbines that primarily supply the blast furnace with what we call wind or lots of compressed air so that process can work. So if that blower station is located close to the blast furnace, number 5 blast furnace and number 6 for that reason. But in that station, we have a number of boilers and 8 different turbines doing lots of different things. So from an energy perspective, the biggest 2 things are that at the coke ovens and at the blast furnace, we generate fuel, what we call indigenous fuel, and we want to make use of that fuel throughout the site as much as possible. 80 terajoules of fuel a day, of which we consume hopefully nearly all of that. So some places around the plant, like the hot strip mill, the plate mill, the furnace itself and the batteries use that fuel directly, and it's our job to make sure that it's distributed to them in the quantities that they want. The rest of it we use in our boilers. So whatever's left over we use in our boilers to make wind for the furnace, to make compressed air for the site, air that we can turn into oxygen and nitrogen. And then if there's any left over still, we generate electricity to supplement the electricity that we buy. And then we've got to distribute all that energy, so in the form of fuel or wind or steam or air or water, natural gas included, around oxygen, nitrogen, around the site to everybody that wants to use them, because nearly everybody has a tap somewhere that they want to turn on and get something out of. And so our job is to make sure when people turn their taps on, whether they're gas taps or water taps or whatever they are, that the right thing comes out and they can happily make steel.
How did you come to this role, and can you tell me about your background and what led you to the position you're in today?
Sure. So I'm a chemical engineer by training, and I started at the steelworks straight out of school as a cadet a long, long time ago. I started in what was then called the combustion department, which was basically process engineers, and I was based down on site at the blast furnaces, of which were 4 and number 5, and I spent some time there in the operational departments and the maintenance departments providing that process engineering advice. After that, I moved across to the coke ovens and into operations directly, primarily focused on gas processing, where I spent about 18 years there. And then about 12 years ago, I moved back to energy services. I had done some work in energy services when I was working with the blast furnace, because there's obviously a close synergy between the two. So I was back here in 2010, and I've been here ever since.
Now, you brought up gas in there. It is an important feature and I suppose the theme for this episode, but it does link to a lot of other things, like you said. What can you say about the importance of gas at BlueScope and its operations? And I also understand you mentioned before the recording that you actually had an earlier connection with Richard Ainsworth, who's in this very program. Can you maybe talk about the work and the crossover that you've had with him as well?
Sure. So to answer the first part of the question, gas, yes. So we make a lot of gas in our coke ovens and blast furnace operations. And most of our major steel making chain at the Port Kembla site depend on those fuels for their operation. You can't run a battery, you can't run a blast furnace, you can't run a BOS, you can't run an oxygen plant, you can't run a hot strip mill, and you can't run a plate mill or a lime kiln or any of those facilities without that gas, or at least the products derived from that gas. So it's all around the site. It's everywhere when we walk on this site. And I feel like I've been playing with those gases for a long, long time. One of the things that I've learned is that you can't take them for granted. They're toxic and they're explosive. And the moment you start thinking you have them all under control, you're in trouble. So you've got to have a respect for not just the energy that's in them, but the toxicity of them. That's always our number one concern. Anyone asks me, what's your number one safety concern where you work, Ian? I say gas, and specifically the carbon monoxide in the gas. You can't see it, you can't smell it, but it can be deadly. So there's gas is important, but it's also dangerous, or there's a risk involved with it. So we have to make sure all those risks are controlled. When I first started here as a cadet, Richard was a cadet a few years before me as well. Same engineering, same pathway. So he was one of those people that when you're straight out of school and he already has 2 or 3 years experience, seems like someone that knows everything. And maybe he did in those days, but yeah, seems like he knew everything. And then when I started working at the blast furnace, he was the senior process engineer there for quite some time. So I worked for Richard in those early days, working in and around the blast furnace. I learned a lot of things about gas and the way it was used at the furnace from Richard.
And did you go on to have other collaboration or shared teams with him, or where did that lead you, your work with gas elsewhere in the organisation up until now?
Absolutely. So as Richard got more into the gas safety space and the gas regulation space, he was always there as the either source of knowledge or collaboration or advice for whatever we were doing. So most of my career has been spent operating plant that uses or produces the gas or does something to the gas. And so we're always operating within that framework of what are the requirements, what are our regulations, what are the safety aspects. So there's always that discussion that goes on, and Richard was always the one or one of the ones that we would talk to about what we were doing in some form or other. So, yeah, the collaboration has continued for a long, long time in terms of what we did.
That's fantastic. It's good to have long-term friends or colleagues or connections you can draw on throughout your career, I understand. Something that's stood out to me in what you've been talking about is, you've said words like toxic and dangerous, and you've emphasised that need for safety and awareness of gases that maybe you can't detect just as an average human being. You need these sensors or systems in place. That could be very interesting, I suppose, for people who are joining an organisation, younger generations coming in. It doesn't sound terribly appealing, to put it bluntly, that you might be working with this stuff. In fact, when new people are coming in or they're switching teams or they're working with these technologies and gases for the first time, what kind of things do you communicate, or what kind of onboarding or training exists within this framework and these regulations to make sure that people are aware but also comfortable?
Sure. So we should never talk about the risks without talking about the controls that exist alongside them, because they're the things that we can control. Yes, there's a risk involved with this, but what are we doing about it? We're putting in place controls. The skeleton of the framework is in the gas regulation. So we have 4 levels of gas safety training. And so typically if we're in the department that I work, everyone here would get gas safety level 1, which is effectively an awareness type training. We would also do some training with monitors, and we would do that as early as we could. Even before that, in our inductions, the first thing that comes up about, you're going to be walking around here about, hey, there's a hazard called gas. Please do what you're told. Please pay attention to all these monitors that we've got off, and if a siren's going or a light's blaring, get out of the area, ask someone. So right at the start, we do that, but then we would work them through. For everyone that works in operations, we would at least then move on to gas safety level 2, which is a bit more than an awareness. It gives you a bit more expertise in use of the monitors, but also some of the fundamentals of gas safety, and allows you to follow standard procedures to work with those gases. Then a number of people, typically supervisors or other leaders or engineers, would become gas safety level 3. That allows them to write our safety procedures and our isolation procedures, our gas procedures, and also to enact them. And then a few really lucky people get to be gas safety level 4, which allows them to check the procedures and sign off that they're compliant with the gas regulations. So that's the fundamental framework we have on. We then do a lot of other training around the equipment that we have. And so if we're training someone to operate a boiler, for example, there would be a lot more that goes on about the specifics of the gas in the boiler, how it burns, what particularly there is about that equipment that you need to know. But that's built on that fundamentals that are sitting there in the gas regs.
I'm assuming that, once people have achieved these levels of safety, the discussion doesn't stop there. This is something that comes up on a daily basis in projects, daily work.
Absolutely. We're probably doing some form of gas or hazardous isolation a couple of times a week to do the maintenance. And there's always a few people involved. As every one of those jobs, the first thing we talk about is how we're going to isolate it. Which procedure are we going to use? Is this procedure still valid? Is it appropriate for the scope of work? What's going to happen? What's the PPE we need? We're reviewing the results of the monitoring every day to see if any of our fixed monitors have done something unusual or gone into alarm. We do have people 24/7 watching all of the monitors that we have around the site to see if any of them go off, just there's some sort of incident going on. So particularly for within the blower station, we have the boiler controller, and then for outside we have the energy centre controller who's watching all those things. But yes, every day we're talking about what's going on with our gas systems. Are they okay? Are they operating properly? What do we need to fix? So that discussion happens definitely every day.
And with so much to think about, what would you say that you enjoy the most or get the most out of working in your current role with BlueScope?
Safety is obviously the ticket to the game, and getting jobs done safely and walking home at the end of the day is a good feeling. especially when it goes to plan, it's done on time and you think, yep, we got that right. The forward end of that is gas is energy, right? It's a big form of energy. There's a lot of exciting stuff happening in the space of how we use our energy, how we be more efficient, how we transition to different forms of energy, which we're looking at. And so all of that understanding, how we integrate all this together in the steelworks, what are the best solutions? There's a lot of work going on in that space. And to do that, coupled with keeping the plant running today and tomorrow and the next day, is interesting and sometimes exciting, but always enjoyable.
That's a great summary. Is there anything that I haven't asked you about your career or the different assets and energy that you work with that you'd like to cover before we finish?
The most visible part of this for most people are probably the gas holders that you see along Five Islands Road. So there's two big tanks that look a bit like AA batteries, oversized AA batteries. One of them holds coke ovens gas and one of them holds blast furnace gas. It's a visual thing that people often outside of BlueScope ask me, what do I do there? And I go, well, you can see those two tanks and you can see those flares. When I can't see any gas bleeding off, I'm a happy person. When I can see some gas bleeding off, I'm on the phone going, hey guys, what's going on? But there's a lot of gas inside those two batteries. They're floating up and down. There's pistons inside that float up and down on the gas. They don't store a lot because we go through a lot. Just to give you an example, we tell people that if one's full, that holds about 30 to 40 minutes supply of gas for the site.
Wow.
So it's not a big storage unit. It's really just about controlling the pressure. But they're just the most visible thing that people often, between that, clouds of steam from the quenchers or other places and the gas flares, that's a lot that the community see about BlueScope. So that part of the job's interesting as well.
No, that's a fantastic piece of behind-the-scenes knowledge, and we'll have to make sure to include some images of what you're talking about in the links and show notes for this very episode. So if you're listening and you're wondering what Ian's talking about, visit the show notes and you'll see the gas holders. Well, this has been really interesting, Ian. Just wanted to say thank you very much for joining this episode of Voices of BlueScope and sharing your expertise.
No problem. It's been a pleasure.
Let's move to Jennifer, who describes her fulfilling work in process engineering, the thrill of problem solving, and what it's like to train and collaborate with graduates.
So my name is Jennifer Blood and I am the lead process engineer for the coke making and iron making department at BlueScope. So we're the primary end of the operations. So we include the coke ovens, which take the raw coal and convert it to coke as a feed for the blast furnace. And we also include the cinder plant, which takes the raw iron ore materials and the various other fluxes required, such as limestone and dolomite, and put that into a good feed for the blast furnace. And then I guess our main area is also the blast furnace, where we make the molten iron from all the raw materials. When I first came as a very young engineer, I spent about 9 months at the tin mill, which has since closed down. Apart from that, I've spent my whole time at coke and iron, mostly at number 5 blast furnace itself.
Fantastic. Now, can you tell me when you started at BlueScope and what brought you here?
Well, I came as a contractor back in 2005. I came to the tin mill area to help out with major hazardous facilities and some dangerous goods auditing. I was there for 9 months, and then I came across again as a contractor to the iron making process engineering team. At the time, back then, coke making and iron making weren't combined as one department. They were separate. So I worked for iron making engineering for 6 months, just helping out with some projects I had going. And then the opportunity came up for a BlueScope permanent position at number 5 blast furnace. And I applied, and that's when I made the jump from contractor to BlueScope employee. That was back in early 2008.
And what was it like to start that permanent position with BlueScope and work at the blast furnace?
Oh, it was excellent. I was very happy. That's what I had found as a contractor is I personally operate best getting to know a process and know it really well. So it really suited me.
Now, the blast furnace is an interesting thing in general, but I think a lot of people, particularly in the Illawarra, would drive past the steelworks and see these big structures, these blast furnaces, and maybe not even know what they are. What's something cool or interesting that you learned early on with your time at the blast furnace that has stuck with you?
As a process engineer, I had never really thought how much process engineering was involved. I saw it more as a materials, raw materials, rocks going in, liquid coming out. I hadn't thought about the amount of cooling systems that are required. We have 4 major cooling systems now on the furnace, just because of the amount of equipment that needs cooling and just, the amount of work that goes into that, and our stoves and hot blast, heating up the blast that makes a blast furnace is something that's important to do, and then dealing with the gas that comes out in the water. I hadn't realised just how much was involved in what you think sounds like a simple process of putting rocks in and melting them and getting the liquid out.
Now, you've mentioned a bunch of processes and resources there, but one that sticks out in what you said is gas. And in this episode, we are exploring that particular resource. What's your experience with gas and broader implications or regulations surrounding safety and how it works with manufacturing?
I guess as a process engineer with the chemical engineering background, we're one of the people that other people generally come and ask about gas safety, because a lot of the operations people will have a lot of practical experience, but I guess as chemical engineers, we're supposed to have the technical knowledge around gas and its processes. So I've always been quite involved in that time. Before I got here, there was a fairly serious incident at number 5 where a couple of people got exposed to gas and collapsed. And so that has always made me pretty interested in it, because our main gas here at the blast furnace gas, you can't smell it, you can't see it. The only way you know that you're exposed to the gas is via a gas monitor. And so it's just so important to have those, I guess, controls and processes in place. At the furnace, we have such a large network of gas pipes. And so the nature of equipment, something will go wrong and we need to write a procedure. We need to work out how we're going to fix it, which means writing an isolation procedure. And as part of that, you have to refer back to those gas regulations to understand what kind of isolation you need, whether you need to purge it, whether you need to just have one valve, or whether you need to put in like a slip plate for a more positive isolation, what kind of work you can do on different gases. So refer to that all the time to write gas procedures.
And how often do you need to revise or revisit things, or is it fairly static and set in stone?
Well, all of our procedures, most of our procedures generally have a 4-year review period. So our standard procedures, we review every 4 years. A lot of the times not much changes, but we also, things break down occasionally, and then we don't have a standard procedure for every possible scenario. So we will have to write a new one quite regularly. And sometimes you're trying to write them pretty quickly because something has happened and there is a gas release and you need to have a procedure so that people know how to make it safe.
And when you meet people outside of BlueScope, maybe it's a social event, maybe even family members, and they ask you what you do you find it easy to explain to people what you do?
No.
How do you communicate what goes on at work?
It's really hard to explain. Even my sister, she is a chemical engineer by trade, but she went into research. So she did a PhD and has stayed as a research associate and runs a research hub in Melbourne. We have the same background training and neither of us understands what the other person does very well. It's very hard to describe, especially, I guess, chemical and process engineering. It's less understood sometimes than the mechanical and the electrical. So I tend to try and tell people that the chemists come up with a process of how to make something, and then we essentially make it very large scale from a lab scale is how I try and approach it, I think.
No, that's a good breakdown. And what is it about some of the theory or the ideas that go into it? Because working in an industrial site, and I think this is the distinction you were making with your sister working in research, they're dealing with information, probably piles of it, but you're having to go out and do stuff with your hands, with tools, with automated procedures and processes. What is it about that topic or that academic field of chemical or process engineering that you enjoy putting into practice?
I guess maybe it's more the logic and the problem solving. So I guess as chemical and process engineers, we tend to know how an entire process works. So if I have a problem on a cooling system or a gas system, if there's one flow that's not working correctly or something, I need to understand how the whole system works together to really understand what the problem is. And some of the best part of the job for me is coming into work and someone says, this has been a problem, this is not working this flow is higher than it should be or something, and then trying to figure out why, and then getting it right, I guess, solving that problem. I'm very keen on sharing knowledge. It's one of the things that I like to think I do quite well. I'm quite a documenter, so I document a lot of things. We'll have an issue that'll have been a bit different, and I tend to just write a quick note of what happened and how we found it, and then I save that to a series of folders, and it's available for anyone for the next person that comes into that role, they automatically get all these folders. It's not saved on my hard drive. I don't take any of that information with me. I like to have it available for anyone to see, because I know in the past I've been in that situation where you're trying to figure something out and someone goes, oh, this happened 3 years ago. And you're like, well, there's no record of it anywhere of what happened and what they did. So I try and keep good records to pass that information on. So at the moment, as the lead process engineer for Coke and Iron, I have 2 graduates that work for me, and I'm about to employ a 3rd one starting in January. So training new people is a bit of what I do at the moment. And the main thing, I guess, is we just try and involve them in as many things as possible. So we try and get them out and about to see the plant. I think one of the best ways to learn it is to see the equipment and the processes and be involved in them. So anytime someone that we know is going out to look at something, we try and get that person to take the graduate along with them, just go out there and see and learn, and then also try and assign tasks that cover a variety of things. I don't want a graduate given a boring task on an Excel spreadsheet and sitting in an office for a week. They need to be out there touching and seeing and learning. For me, the role that I'm doing at the moment, I really enjoy. I feel there's so much more to learn at the moment, because I've gone from looking after the blast furnace to help looking after the cinner plants and coke ovens. And I feel there's so much more for me to learn there. And I'm also really enjoying training the new people up and then seeing them. One of the people that works for me has gone from a graduate and he now looks after the coke ovens. So seeing that growth is really satisfying to me.
That's a great message. So keep sharing knowledge. And if there are people out there who have an interest in this career or learning the importance that BlueScope puts on safety, this is a good career avenue then.
Yes, I think so.
Perfect. Well, thank you so much for your time on Voices of BlueScope, Jennifer. It was wonderful to hear your story and thoughts on this important topic.
No worries. Thank you.
Last, we turn to Krishan, who is Richard's successor. He shares his experience working between operations and engineering and asserts the need to share knowledge across disciplines and teams.
Yep, so my name's Krishan Kumar. I'm a process engineer who started here as a cadet in 2009. I've been with BlueScope for now 14 years. I spent most of my time as a process engineer at coke making. Now I'm just moving into a new role with capital development and engineering.
Fantastic. And how did you find that cadet experience when you joined?
It was quite good. I do feel like it was a lot to take in when I first started straight out of school. Like at the moment, we've been hiring a lot of graduates, and you can see that they come in with a better understanding of process engineering. But for me, it was a great experience to learn about heavy industry and also meet a lot of cool people and get a lot of experience in that time.
And what was it like to have to balance that theory and practice, training on the one hand and taking in all of this university study, but then going out and working in manufacturing?
It was definitely better. It was to our advantage at uni because we knew what was important at uni and what was more in theory that we wouldn't use that much. We definitely, with some skills like P&IDs and documents, we had a lot more skills than people that were in uni and had only written reports for university, whereas we had written reports for real-life applications. I think that the cadetship program was definitely, it was good for us, and that we had a lot more confidence in calculations and applying the things we were learning at university to the real world.
And from there, when you finished your cadetship, what led you to where you are now, working with Richard, who's also featured in this episode, and now taking over from him? Tell us about that journey.
It's probably luck more than anything. When I graduated, there weren't a lot of jobs going on around the steelworks, and I think in the years after me, the cadets weren't offered jobs directly when they finished their cadetship. And I guess I always wanted to stay in Wollongong and stay with BlueScope, so I took any job that came to me. And so my first job was with an operations team, not doing that much process engineering, but still doing enough to remember my degree. But it was more focused on operations and how we can increase our coke production and fixing problems that the operations teams had with a bit of engineering involved. So maybe only 20% engineering. So
how was it different for you working in operations when you had been training or learning with an engineering background?
No, it was okay. I think an operations job gives you a chance to work on a broad range of skills that sometimes don't get in engineering jobs when you're seeing it off as calculating or working on projects. So I definitely felt time in operations is really good, and it can work with your engineering degree to give you a broad range of skills, I think. So I guess the difference is about priorities. And so in operations, we're focused on getting whatever the problem is in front of us resolved. Whereas in engineering, you've got the same job, but you have to also consider a broader range of standards in engineering design and things like verification calculations, design procedures. It got a lot more involved in that in the last few years. Whereas in operations, those things are a bit more secondary in your mind.
What can you tell us about the field that you're working in now and that move to assume Richard's role?
Go back a step to gas safety. The whole time I've been at the Steelworks, we've had the gas regulations, and gas safety has been a priority for all process engineers around the place. But I think it's been interesting working at coke making particularly because there are a lot of older guys there that remember a time that wasn't the case. And I take for granted that the gas regs are there, but there was a time when those procedures didn't exist, and the way we handle gases, it wasn't as safe as it is now. In particular, there were guys around coke making that had heard about the 4-battery explosion that sort of triggered the making of the gas regs. It's good to see that there's people there that also know what life can be like without those gas safety standards. And I think over time, we sort of not take it for granted that the gas regs is a bit of our corporate knowledge that really changed the way we do gas safety. There probably are companies out there that make their own indigenous gases that don't handle them very safely because they haven't had the same people come through with the same experiences that we've had. And we can't take for granted that we have good standards around the gases that we make.
There was a term that you used in there that I really liked. You said corporate knowledge. There's corporate knowledge in terms of standards and regulations and documents that you were just talking about, but then there's also knowledge that's passed through working with people or sharing ideas on the job that might not be formalised. What can you say about that sharing of knowledge in those two ways, having worked with Richard and other people who designed these formal regulations but might have said more in the collaboration with them directly?
Oh, definitely. There's a lot of guys here that if you get them involved in meetings or they come out and have a look when you've had incidents, they just pass on an insane amount of knowledge. And so Stuart Gaynor's another person who has a lot of stories that help you bring things into context. They're big incidents that hopefully we don't have them again, but because we've had them, they have an understanding of what causes those incidents and what doesn't. So I think even around dust explosions, Richard had told me that he was involved in some baghouse fires that we had on our coal drying mill. And he came to a meeting where we were looking at putting a baghouse in for coal, and he was able to discern why ours would be okay, but that one wasn't okay because of the design and the particular conditions around that. But that's information that it's not written down anywhere. You just have to get the right people involved and hopefully they can pass it on. And Stuart's the same. Stuart's come to meetings and passed on a lot of really good advice to us as a team. I think I've been working with him on some putting in a triple VF, so a variable voltage variable frequency drive at Coke Plant 1. It's nearly like having a cheat code for a project because he's done it before and he can give you all this advice that you can sit down and risk assess, but you may not think of. So it helps you to get it right the first time. So
that's great. So you're constantly sharing stuff throughout different meetings and while working with other people. That's really good. This is somewhat of a direct question, but did you feel any pressure in assuming this role from someone who had designed or at least led a lot of these introductions of different standards and regulations, with that deadline that he was retiring? What was that like, knowing that you had to capture information for now and the future?
Oh, definitely. Even when I applied for the role, I didn't think I had a chance because I was like, this is Richard Ainsworth. This is not a role I'm ready for or not a role I could do. But here I am. And so I think having worked with Richard now in the handover, I think it's definitely something that I can do. But I think what's been interesting is it's just his diligence in recording and slightly updating and tweaking our gas safety procedures and gas regs to keep up with modern times. That's the interesting part of it. It's not that he's like super smart or does something special, but he's just so good at recording and keeping information so that everyone can learn from our mistakes and everyone can learn from things that we've thought about or learned around the steelworks.
And of course, you'll put your own mark on things and you have your own future in this role and perhaps in other roles. On that topic of the future, where do you see yourself heading and where would you like to take things?
I haven't thought that far ahead, I guess. I never really look more than one job at a time. So as far as I can see, I'll be sitting at this desk for a while. I mean, Rich has done a really great job with the gas regs and with training of our GSL 3s and 4s. So at the moment, I can't see doing much more than maintaining the systems he's kept up, which in itself means changing them to like adapt to our challenges for the future. So yeah, like we've talked already about having to introduce hydrogen into the gas regulations and updating our sort of oxygen standards for the future. Yeah, other than tweaks, I can't see it being too different. We already do a very good job, I think, now of managing our coke ovens gas and blast furnace gas hazards. So.
Well, that's a great point you bring up, hydrogen, and hydrogen's part of a broader theme or strategy for sustainability, not just at BlueScope, but in many different industries. Is that something that you think about actively every day, that idea of sustainability, or is it more of a long-term future thing? How does that enter your mind?
This team, it's something that our boss Shannon's been thinking about a lot. I guess we have some experience with hydrogen already, like it's already a big part of the coke ovens gas mix. But I think the interesting part with our hydrogen future is going to be the higher pressures and also the new technology required to produce it. Like hydrogen itself is something I think we can handle, but it'll be the way we design it that'll make a difference. So,
is there anything that I haven't asked you about with your role or personal experience or what you're up to that you'd like to add to this interview?
Yeah, I guess the one I can think of is, so I did an operations role for quite a long time. And then before stepping into Richard's role, I swapped over to an engineering team. And so I'd only say, if anyone's listening, that it's good for engineers, even if you work in operations, to touch base with an engineering team and keep your engineering skills sharp, because the engineered solutions I find are a lot sometimes better than just the quick fixes that you see sometimes in operations. And I think that in the future, we're probably going to need more engineers to know our engineering systems and not just the operations side. So,
well, I don't know if you intended it this way, but that connects nicely back to that theme of sharing knowledge in an organisation.
Thanks. Yeah, I'd also say that there's a lot of people out there to help. Probably early in my career, I didn't call on those people enough. And so in hindsight, it would have been better to be picking up the phone and calling up. Well, I guess it'll even be people like me and Shannon and Stuart if you need help. So there's always people around that can help you out. So.
Well, that's fantastic. Thank you very much for sharing your experience and knowledge on the podcast, Voices of BlueScope. Great message for anyone who's assuming a role or taking on new challenges from earlier generations in a company.
Thank you.
We hope that you enjoyed all 4 interviews in this episode, and we thank Richard, Ian, Jennifer, and Krishan for sharing their insights and experiences with us. To learn even more about our people, products, and processes, make sure to visit bluescope.com, BlueScope on LinkedIn, and TV BlueScope on YouTube. Thank you for listening to Voices of BlueScope, and we hope to have you again soon.